Good morning, student. Welcome in e-learning section of C. Saiva English Medium School, Shirdi. Today, we are going to start our third lesson, Arithmetic Progression. Okay, this lesson is new for us. Okay, in that arithmetic progression, we study about the numbers. In that, we see the sequence, terms of sequence, what is mean by arithmetic progression, n term, sum of n term. Now, in this topic, we will study in this lesson. Okay. Now we start our third lesson, arithmetic progression. Now, in that, the first topic is sequence. First thing, what is meant by the sequence? In that word, the sequence means there is one relationship between the two consecutive not consecutive, it is consecutive terms. So suppose we see first example, definition of sequence: a set of numbers where the numbers are arranged in a definite order. Okay, a set of numbers where the numbers are arranged in a definite order like the natural numbers is called a sequence. You know that the natural number start from 1 2 3 4 5 6 7 and so on. Here the every number which has definite order, you know that the on fifth place of that set of number, which number? Fifth. That's why the set of number where the numbers are arranged in a definite order. Okay, we write the numbers 1 2 3 4 in order. In this order we can tell the position of any number. For example, number 13 is at 13 position. The number 1 4 9 16 25 36 49, these all are the perfect square of 1 2 3 respectively. Now here at the fifth position, which number? 25, and 25 is the square of 5. On 7th place, which number here? 49. That's why here the 49 is the perfect square of 7. Okay, similarly 16 on which place? 4th place, and 16 is the perfect square of 4. That's why in a sequence every number having the definite position or a particular position, and they arrange in definite order. Okay, this is the sequence. The so many examples of the sequence, whole numbers or tables. Suppose the table of 2, table of 3, table of 9, whatever, they are all are the examples of sequence. Okay, now in a sequence a particular number is written at a particular position if the numbers are written as a1, a2, a3, a4, then a1 is the first, a2 is second, and so on. It is clear that an is at the n place. Okay, a sequence of the number is also represented by alphabet f1, f2, f3, and we find that there is a definite order in which number are arranged. Okay, now here suppose we write in sequence of the form a1, a2, a3, a4 up to dash or dot so on. Here a1 is represented by a1 is represent first number of a sequence, a2 second position, a3 third, like that, a4 fourth, 8 and 10 position, and an represent the n position of a sequence. Okay, second place of a sequence. Okay, now here generally we represent sequence with the help of f1, f2, f3, so on, and we find that there is a definite order in which number are arranged. When students stand in a row for drill on the playground, they form a sequence. Yes, because for the drill we arrange student height wise. Okay, that's why this is also the sequence of student. We have experienced that some sequence have a particular pattern. Okay, in particular sequence in sequence they having the particular pattern. Now suppose we see one example. For example, 4, 8, 12, 16, and the second example is 2, 4, 8, 16, 32. Okay, in these two sequence, in the first sequence 4, 8, 12, 16, here in that sequence the first number is 4 and second number is 8. Now here in between 4 and 8, the difference between them is 4. We consider next consecutive terms 8 and 12. In that 8 and 12, again the difference between them is 4. Similarly for 12 and 16, 4. Now means here in that sequence this have a means here the particular pattern. For the second sequence 2, 4, 8, 16, 32, here also in between here the 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, like that. Means here the particular pattern. Okay, here the this number is if you multiply the previous number by 2, we get the next term. Okay, this is a particular pattern in that sequence, and that group of number or the set is the sequence. Okay, now we see the third example. In that third, 1, minus 3, 5, 9, 10. See in this set of number here 1 minus 3, here minus 3, 5, 5, 9, 9, 10. There is no particular pattern. That's why the given set of number or group of number is not a sequence. Okay, understood? Now we see the next topic. Our next topic is terms in a sequence. Terms in a sequence. Terms in a sequence means, for example, 1, 2, 3. Okay, in that the 1, 2, 3, 4 are the terms, and in a sequence order terms are generally represent as T1, T2, T3, Tn. In general, sequence is written as in curly bracket Tn, T suffix n. Okay, in a sequence order terms are represented as T1. T1 means first term, T2 means second term, T3 means third term. Okay, and the n term is Tn. In general, sequence is written as represented as in curly bracket Tn. If the sequence is infinite, for every positive n there is term Tn. For example, if n is equal to 10, then T10. Okay, now the next activity first. We see the two activity here. Activity first, in that the sum sequence are given below. Show the position of the terms by T1, T2, T3. Okay, now we see the first example. 9, 15, 21, 27. Here T1 is equal to 9 means first term, T2 is equal to 15 second term, T3 is equal to 21 is the third term. Okay, now we see the next example or the sequence 7, 7, 7, 7, 7, so on. Here T1 is equal to 7, T2 is equal to 7, T3 is equal to 7. Means here first term 7, second also 7, and third also 7, and so on. Tn also 7. Okay. Now the next example. -2, -6, -10, -14. There is particular pattern in that all these three examples. Okay. In the first 9 plus 6 15, 15 plus 6 21, 21 plus 6 27. In second 7 plus 0 7, 7 plus 0 7. Okay. And in third one -2, -4, -6, -6, -4, -10, -10, -4, -14. Here T1 is equal to -2, T2 is equal to -6, T3 is equal to -10. These are the terms of in a sequence. Okay. And the generally terms of a sequence represented by T1, T2, T3, T4, and so on. Okay. Now we see the second activity. In that second activity, some sequences are given below. Check whether is any rule among the terms. Find the similarity between two sequences. Okay. Now here the first example 1, 4, 7, 10, 13, and the second example is 6, 12, 18, 24. Third example 3, 3, 3, 3. Okay. And so on. Fourth example 4, 16, 64. Fifth example -1, -1 by 5, -2, -2.5, 6, 1 cube, 2 cube, 3 cube, 4 cube, and so on. Now we see what is the relationship between them in next slide. Okay. We continue this. Okay. Let us find the relation in this sequence. Let us understand thought behind it. Okay. Now see here. Here the first sequence is given 1, 4, 7, 10, 13, and so on. What is the relation in this two consecutive consecutive means continuous. Here the 1 and 4 are the consecutive terms, 4 and 7 consecutive, 7 and 10 consecutive. What is the relationship between them? The particular pattern here, which is now we see here. If we consider the first term T1 is 1, and if we add in that 1 which number 3, then 1 plus 3 we get 4 here. Now the next, if we consider the second term, okay, 4, then 4 plus 3, what we get here? 7. Okay. After that, if we consider the third term 7, okay, now in that 7, if we add 3, what we get? 7 plus 3 10. Similarly, if we add 3 in 10, what we get here? 13. 13 plus 3 16. 16 plus 3 19. Like that, this is the particular or the relation in this sequence, or there is a particular order. Okay. Now we see the second example 6, 12, 18, and 24, and so on. If again the similar here the 6 plus 6, 6 plus 6 12, 12 plus 6 18, 18 plus 6 24. Means here that there is a relationship between two consecutive terms. If we add 6 in if we add the 6 in previous term, we get the next term. Okay. Means that there is a particular relationship between two consecutive terms. Okay. Now we see the third one. In that same third one example, here the sequence is 3 3 3 3 3. Okay. Now here if we add 0 in 0 in each term, then what we get here? 3 3 3 plus 0 3 3 plus 0 3 3 plus 0 3. Okay, means the above three sequence, in that if we add a particular number, then we get next number. Okay, now we see the fourth one example. Okay, in that fourth, the sequence is 4 16 64 to 56. Now in this sequence, if we add a particular number, then we can't get the next number. If we multiply a particular number, then we get the next number. We see here. Here, if we multiply the previous number by the particular number, means 4 4s are 16, 16 4s are 64, 64 4s are 256, like that. Means here, if we multiply the particular number in that fourth sequence, then we get the next number. Means there is a particular pattern here in that in all this first sequence. In that the first three sequence, if we add a particular number, then we get the next. In fourth sequence, if we multiply the particular number, we get the next term. Then what we conclude here? Here in the sequence 1 2 3, the similarity is that next term is obtained by adding a particular number to the previous number. Each of these sequence is called an arithmetic progression. Here in the sequence 1 2 3, the similarity is that next term is obtained by adding a particular number to the previous number. Each of these sequence is called an arithmetic progression. This is our main topic in this lesson. Okay, what is mean by the arithmetic progression? If we add the particular number in each term, then we get the next term. For example, 1 plus 3 4, 4 plus 3 7, 7 plus 3 10, 10 plus 3 13, 13 plus 3 16, like that. This is our means here example sequence number 1 2 3 are arithmetic progression. What about fourth number? We see the fourth number. This is not in this here. This sequence we will see 11 or 12 standard. Means here sequence 4 is not an arithmetic progression. In this sequence, the next term is obtained by multiplying the previous term by a particular. This type of sequence is called a geometric progression. Okay, if we multiply particular number to each term, particular number to each term, particular number to each term, then we get the next number. This sequence is known as geometric progression, and this geometric progression for we will study in 11th or 12th standard. Okay, now we in this lesson we only study we see the arithmetic progression. Okay, now we see the actual definition of arithmetic progression. Okay, in the given sequence, if the difference between two consecutive terms in general tn plus 1 minus tn is constant, then the sequence is called arithmetic progression. Okay, again I repeat definition. In the given sequence, if the difference between two consecutive terms tn plus 1 minus tn is constant, then the sequence is called arithmetic progression. Okay, arithmetic progression. In the previous example, which the example sequence 1 4 7 10 13 16 19. In this the difference between the consecutive terms is 3. We add the 3 in each. That's why the difference between two consecutive terms are constant. That's why this is an arithmetic progression. Okay, now we see the next. Here the Tn plus 1 minus Tn is equal to D is the common difference. Here the common difference is represented by D. In an AP is a short form of arithmetic position. If first term is denoted by A and common difference is denoted by D, then we get sequence. Then T1 is equal to first term is equal to A, T2 is equal to A plus D, T3 is equal to A plus D means A plus 2D. For the T4, A plus 3D. Okay, AP having first term A and common difference D is A plus D, A plus 2D, A plus 3D, so on. Examples of AP. First example is 5, 12, 19, 26. See here. Here the first term is 5, second term is 12, third 19. Means here T1 is equal to 5 or A is equal to 5, T2 is equal to 12, T3 is equal to 19, T4 is equal to 26. Here if we find the difference between two consecutive terms. First term T2 minus T1 7, 12 minus 5 7, T3 minus T2 means here 19 minus 12 26. Sorry, 12 7 means the difference between two consecutive terms are constant. That's why the 5, 12, 19, 26 are constant. Is an AP. Why? Because D is equal to 7. Now here the second 2, 4, 6, 8. Is it AP? Yes. Why? Because here the common difference D is equal to 2. Here the 0, minus 4, minus 8, minus 12 is also an AP. Now we see the examples on AP. First, some topic remember here. Let us remember the first one. In a sequence, if difference Tn plus 1 minus Tn is constant, then the sequence is called an arithmetic progression. Note that. Note, in an AP, the difference between two consecutive terms is constant and is denoted by D. Difference D can positive, negative or 0. The difference of two consecutive terms or the common difference is maybe positive, maybe negative or 0. Okay. In an AP, if the first term is A and the common difference is D, then the terms in the sequence are A plus D, A plus 2D, A plus 3D, A plus 4D and so on. Okay. Now we see the examples. We check whether the given, first we check whether the given sequence are AP or not, and then if you are AP, then find next two terms. Okay, which of the following sequence are AP? If it is an AP, find next two terms. Okay, the first sequence 5, 12, 19, 26. Second 2 minus 2 minus 6 minus 10. Third one 1, 1, 2, 2, 3, 3. Okay. Now in the we consider the first, we find the solution, or we check whether the first sequence is an AP or not. Okay. Solution. In this sequence 5, 12, 19, 26, first term T1 is equal to 5, T2 is equal to 12, T3 is equal to 2. Not here by mistakenly it is T3 is equal to 19. Okay. Now here T2 minus T1, 12 minus 5, 7. T3 minus T2, 19. Sorry, 19 minus 7 minus 12, 7. Means here the difference between two consecutive consecutive terms are consecutive terms are constant. That's why the here first term is 5 and the common difference which is constant is d is equal to 7. Therefore this sequence is an AP. Therefore the given sequence is an AP. Now we find the next two terms, means we add the given last term 7, we get the next, means here next two terms in this AP are 26 plus 7 33, then the next term 33 plus 7 40. These are the next two terms. In this way we check the given sequence, is it AP, is an AP or not. AP means arithmetic progression. Now we see the next example. Examples are the 2 minus 2 minus 6 minus 10 is an AP or not. We check here by first we to check the given AP is the given, sorry, not AP, given sequence is an AP. What we do here, first we check we find out the difference between two consecutive. If the difference is constant, then the given sequence is an AP. We see the solution is directly here in the sequence 2 minus 3 minus 6 minus 10. Here t1 is equal to 2, t2 is equal to minus 2, t3 is equal to minus 6, t4 is equal to minus 10. Then here t2 minus t1, 2 minus 2 minus 2 minus 4, t3 minus t2 minus 6 minus 2 minus become plus, minus 6 plus 2 minus 4, means here difference between two consecutive terms is constant or is 4. That's why therefore d is equal to minus 4. It is an AP. Next two terms in AP are minus 10 plus minus 4 minus 14, minus 14 minus 4 minus x minus 18. These are the next two terms of the given equation. Now we see the solution of third. In the sequence is 1 1 2 2 3 3. Now in this example here in the sequence 1 1 2 2 3 3, this is a definitive sequence. They are arranged in particular. But what about the AP? We find out that here the t1 is equal to 1, t2 is equal to 1, t3 is equal to 2, t4 is equal to 2, 3 5 is equal to 3, and 3 6 is equal to 3. Now here t2 minus t1, 1 minus 1, 0. t3 minus t2, 2 minus 1, minus 4. Sorry, not minus 4, sorry, it is my mistakenly, sorry. Here 2 minus 1 is equal to 1. And here 3 4 minus t3 is equal to 2 minus 2, 0. Means here t2 minus t1 is not equal to t3 minus t2. Means here the difference between two consecutive terms are not constant. That's why the given sequence in this difference between two consecutive terms is not constant. Therefore this sequence is not an AP, and it is not AP. That's why we can't find the next two terms of a given sequence. Okay, now we see the next example. Some other example depends on AP. Okay, already we have given in the example second the first two terms a and first term a and common difference are given. In this example we have given the a and d. Find the first four terms of AP. Okay, the first a is equal to minus 3, d is equal to 4. Second a is equal to 200, d is equal to 7. And third a is equal to 6 and d is equal to minus 3. Now here given a is equal to minus 3, d is equal to 4. Now here the t1 is equal to a, then t1 is equal, therefore t1 is equal to minus 3. Okay, now here t2 is equal to t1 plus d, then therefore t2 is equal to t1 is equal to minus 3 plus 4, then here therefore t2 is equal to 1, minus 3 plus 4 1. Now the t3 T2 minus D, sorry, not minus, plus D. Now here, therefore T3 is equal to 1 plus 4 is equal to, therefore T3 is equal to 5. For similarly, T4 is equal to 9. Therefore, AP is minus 3, 1, 5, 9 and so on. Now we see the second example. In this second example, A is equal to 200 and D is equal to 7. Now here similarly A is equal to 200, D is equal to 7, then T1 is equal to A, means therefore T1 is equal to 200. For the T2 is equal to T1 plus D, means here therefore T2 is equal to 200 plus 7, 207. Similarly we find T3, therefore T3 is equal to 214. Similarly we find T4 is equal to T3 plus D is equal to, therefore T4 is equal to 221. Okay, therefore AP is 200, 207, 214, 221 and so on. Now in the same example, in the third given, A is equal to 6, D is equal to minus 3. Now here T1 is equal to 8, then therefore T1 is equal to 6. Now here T2 is equal to the T1 plus D. Now here T2 is equal to 6 plus minus 3, 6 plus minus 3 plus 3. Okay, now the T3 is equal to T2 plus D, then therefore T3 is equal to 3 plus minus 3, T3 is equal to 0, and similarly T4 is equal to 0 minus 3 minus 3, then therefore AP is 6, 3, 0, minus 3 minus 6 and so on. In this way we handle the example on AP. Okay, we check whether the given sequence or AP, and we find out the next two other terms of an AP if we have given the first term and common difference. Again I repeat the some definitions. What is meant by the sequence? Sequence means the group of number or the set of number which arranged in particular order. What is meant by the sequence? Sequence means, sorry, what is meant by AP? In an AP, in a sequence, in a sequence, sorry, not in an, in a sequence, if the difference between two consecutive terms is a constant, means D is constant, then given sequence is an AP. And here A is in first term, T1 is equal to A, and means here the A is the first term and D is a common difference. Okay, for using this we solve the practice set number 3.1. okay, for tomorrow, for today we complete here our first practice set. Thank you.